Hello viewers, Mr. Nyati here with another video, which is a concluding video of section B of the paper 2025 science paper 2, which is GCE. And I hope this has helped you, especially those that are preparing for their final examinations, that is grade 12s who are writing this year. And please, if you feel you need online tuitions, may I suggest that you can just go to my profile. You'll find my number there and be able to contact me for online tuitions. In my next video, I will do section C, question C1 in one video, question C2 another video, and question C3 in another video. And I'll be able to basically do that, so that after this I may now transition to physics, which is science paper 1. Like the video, share the video, leave a comment in the comment section, and also click the bell button so that you're the first person to be notified in case there is a new video posted. Let's just straight go to question B9, which is the last question in section B. What is B9 saying? Well, B9 is saying that the table shows the results of a reaction between copper 2 carbonate and excess dilute nitric acid. So you have copper 2 carbonate and excess dilute nitric acid. Now, imagine you were asked a question to say which one was the limiting reagent, but you've been told already that dilute nitric acid is in excess. So meaning the other one is the limiting reagent. Alright, so you have this table which shows the time that was taken and the volume of carbon dioxide that was evolved during the reaction. And I must mention that because we are talking about carbon dioxide here, it simply means that this is for the products, okay? This is for the product and not the reactant. That's what we ought to know. Now, so this is for the product. So there is also one for reactants where the numbers do not increase steadily but reduce while time is increasing. So you need to understand that. And this topic is on chemical reaction in grade 11. And then the subtopic is rates of chemical reaction. Now, what is the rate of a chemical reaction? The rate of a chemical reaction, ladies and gentlemen, viewers, is basically the speed or the time taken for a chemical reaction to occur, the rate at which a chemical reaction occurs, or the speed of a chemical reaction. Some would want to beautify the statement by saying that it is basically the time taken for the products to be formed or for the reactants to be finished in a chemical reaction, or the change in the amount of reactants or product in a chemical reaction. But the simplest one, which is prescribed in your syllabus, is that a chemical reaction is the speed, the rate of a chemical reaction is basically the speed of a chemical reaction. So now, when you have this, determine the total volume of carbon dioxide produced. What you need to do is to look at the volume that was produced. When you reach at a point where you have this 50 repeating itself 3 times, it means the chemical reaction has ceased, okay? It has stopped. You know, if you were to graphically sketch this, you would basically come up with something like this. Okay, this would be your this side, of course, you would be having your time in seconds, and then this side you'll be having your volume in cubic centimeters, because that is what is given here. Okay, and then your time, of course, it is 0, 10, 20, 30, 40, 50, 60. Which is basically 1 minute, okay? 10, 20, 30, 40, 60, 50, and 60 seconds. Then, of course, you have your your volume increasing steadily like this. It depends how you feel it should be, but it should be 10, 20, 30, 40, and 50, like so. So in this reaction, if you are asked to plot, I want just to show you that at 50 the reaction had already stopped. Let's just put also 60 here so that we have this. This is not an accurately drawn graph, but it's just a sketch trying to amplify the explanation on this part. So at 0 time, the volume was 0. So we have one thing here. And then at 10 seconds, the volume was at 30. So you have a point here. Then at 20 seconds, the volume was at 42. We imagine that this is 42. And then at 30 seconds, the volume was at 48. As you begin to see this, you realize that the graph is beginning to curve. Okay, 48 is somewhere here. And then at 40 seconds, the volume was at 50 cubic centimeters here. And then, of course, at 50 seconds, the volume was at 50. At 60 seconds, the volume was still at 60. So if you are asked to sketch this, this is how your graph would come out like so. Okay, this is how your graph would be. So at this point where you have a constant flat curve of your graph, this part at this point, it means the reaction will have stopped. And if you have a question which says what is the volume, you are going to pick where, at the point where the curve begins to do what? To flatten. And this is the volume. So what is the volume? Which is 50 cubic centimeters, okay? Which is this one here, all right? So the answer to question B9A, Roman numero 1 is what the question is saying, determine the volume, the total volume of carbon dioxide produced. And by the way, look at the mark allocation here, just state it, meaning that it's 50 cubic centimeters or centimeter cubed. Then from there, we move on to question Roman number 2. What is that question saying? The question is actually demanding that we calculate the average rate of the reaction. Now, how do you calculate the average rate of the reaction? So, depending on what you've been given this side and that, you will be able to successfully calculate for as long as you take into consideration of what you have been given. If you've been given mass, then the units for rate of a chemical reaction is going to be grams per second. But if you've been given volume, the units are going to be cubic centimeters per second, okay? If it is concentration, the volume is going to be mole per cubic decimeter per second, okay? Or you're going to say mole per second, which is the same as like this, okay? So now, how is the formula? Well, the rate of a chemical reaction is basically equal to the total volume that you have been given divided by the time taken, okay? And that will be the formula for the volume. So from there, we are going to say rate is equal to total volume divided by the time taken. And what are we going to find there? So already the volume, we know that it's 50 cubic centimeters. 50 cubic centimeters divided by the time taken. What is the time taken? So at what point did we have the 50 cubic centimeters? It is 40. Do not get 60. This is no longer useful, okay? This one is just helping you to have a flat curve to determine at what point did the reaction stop. So it is at this point, this is where the corresponding time is going to be considered from, okay? This is the time that you are going to consider, which is 40 seconds. And from there, you are going to say divided by 40 seconds. Now, we cancel the zeros. 4 into 5, of course, it is 1, remainder 1, then 4 into 1, of course, we're going to put a point, then we add the 0 there, 4 into 10, it's 2, remainder 2, and then when we add the 0, 4 into 20, it is 5. What are the units? Cubic centimeters per given second. This is the answer to the question, and you're going to be awarded with 2 marks for this. The next question, what is the next question saying? We move on to question B. Rock salt is the impure form of sodium chloride in nature. But at this time, we're not going to be asked to calculate the percentage. Should it? Okay, but still the question can come in that form if it was more concept, but this one is dealing with factors that affect the rate of a chemical reaction and all those things. But let's find out what the question is looking for. Rock salt is the impure form of sodium chloride in nature. Briefly explain how you would obtain a solution of sodium chloride from a sample of rock salt. So now when you have a sample of rock salt, we know that rock salt is basically sodium chloride, and when you put it in water, it dissolves, okay? It makes a solution, all right? And once it makes a solution, you can now be able to do what? To filter off some sand particles, because we've been told that it's an impure form. So we can be able to filter off some sand particles and be able to obtain the pure form of it by evaporation and all those things. So let's look at the mark allocation. We've been given 2 marks. So how do we answer this one? The first point is that add water to the rock salt and stir to dissolve. That is the first point. The second point is that filter off the sand and the small stones. Those are the 2 points which are going to equally, okay, and fairly and squarely give you these marks that you will deserve if you put those points, okay? Now they say the next question. Before we go to the next question, let's write the answers to this. So that is the answer. Now one would say, but why didn't we add evaporate or obtain the crystals of sodium chloride by, is it crystallization or evaporation, or evaporate the solution so that you can remain with the solid? Because the question says briefly explain how you would obtain a solution. So this means that we are only looking for sodium chloride in dissolved state, in aqueous state. So we must end here on filtering off the sand and the small stones. We move on to the next question. Name the method used to prepare sodium chloride in the laboratory. In the laboratory, you prepare sodium chloride using sodium hydroxide, aqueous sodium hydroxide, and hydrochloric acid through a process called titration. That is the answer. So for question B2, the answer is titration, not evaporation. Because in a lab, we normally use titration to prepare sodium chloride salt, okay? Ladies and gentlemen, viewers and learners of grade 12 who are preparing for their final exams, this is where I end, and this video concludes the section B of this question paper, and I hope it was helpful. Leave a comment in the comment section, and also take time to go through these videos. You will find that they will be helpful even in preparing you for your final exams. Bye-bye.